Previous to this one, we had already discussed particulate matter and carbon dioxide, and now we are going to continue with carbon monoxide. So let me jump to this specific slide. Okay, hopefully you can all see my screen. Albert is connecting now. Okay. Hi, Albert. We just starting right now. So the carbon dioxide monoxide, working group. One of the questions we asked initially at the survey that we shared with people was about the space adaptability, and we have this featured in some other pollutants as well, like particulate matter and carbon monoxide. For the carbon monoxide community, we received a variety of messages, and it was a little bit divided. So we don't have like an agreement from the majority of the people regarding if we should use it or not. Some people suggested having changes. Some other people suggested having like a target limit. And another comment says averaging concentration over longer periods will mask periods of high concentration and those high exposure. For example, during 8-hour school day in classrooms, which we can understand. Does anyone have any comment here in this working group regarding the space adaptability and carbon monoxide levels?
This is Albert. I'm curious how many, oh, there were 6 responses. I'm a little concerned that there are only 4 of us today, in addition to the note taker.
Right.
So there were more people on the invitation list. Did you hear back from others you expect, or is this all we're expecting today?
So 11 people have confirmed that they're gonna be here, but I mean, what can I say? What can I do?
I know. Well, we could send an email reminder, because I think it's a little short. If you don't mind just resending it to everybody on the list and encourage them to attend. We have an hour, and none of the other meetings have taken that long, so they could get here in 10 minutes and we could still have a more inclusive result. I am curious to hear why people had these different views of the space adaptability questions, which are really 2 questions. I think one is, do we need different limits in different places? But the other is, do we need different time frames, 1 hour, 8-hour ceilings, limits? And again, I would like to see if we could get more feedback on that. But let me ask, if among the group here, did any of you have a strong opinion, one of the minority opinions? I guess we know what the majority opinion is, but I'm curious about these minority opinions. Thanks.
By the way, I've just sent a reminder to everyone. Hopefully more people will join. I don't see someone coming through or raising his or her hand. So I can move on, and later we can come back again if more people connect, if that's okay with everyone.
Let me just mention at this point that I wrote Dustin this morning after trying the Yoo-Hoo. He's the founder of Yoo-Hoo, and expressed concern about the way that product, like many other products, and like this project writ large is proposing, is taking standards or limits proposed for pollutants by regulatory agencies that have a time-weighted average associated with them, and using them as a ceiling, and immediately notifying people when the ceiling is exceeded, and not waiting 1 hour, 8 hours, 24 hours to report that an acceptable average has been exceeded. And I raised this as a matter of concern for all of the GO-AQS standards. If they're based on averages, I strongly support using them as ceilings because it's more protective. But I want to make sure our language is clear to the public and the industry that that's what we're doing, because we're not really using the standards as written. We're using them in this much more protective way to say it's an immediate ceiling to alert you to, and not actually yet. In fact, I don't know of any device actually monitoring averages and reporting exceedances except for personal portables, right? Meant for industry. Thanks.
That's indeed the problem that I have noticed as well. Instruments in general and companies that build instruments, they don't understand the different limits. So they do that exactly what you said. They take those average limits and they use them as a notification for like a threshold notification. And this is why we also developed the GoEQS. We want to have those average limits, but we also want to develop those thresholds for the index in order to accommodate all of those companies out there that they build instruments and they communicate. In this group right now, we have, for example, a sensor manufacturer. And if he would like to share his view on this, it will be great.
Are you referring to, there's only so few of us, is that Lula or
No,
Hero?
Kiro. Yes, Kiro.
Yes, we are. We manufacture sensors, and our devices also has the carbon monoxide sensor inside. And in general, the concern is about okay, the ceiling should be kept. Of course, normally in our experience, the carbon monoxide level reaches indoor not levels not above 3 ppm in general. In general, outside in outdoor, we measure something like 1 ppm as average. Something below this, the main concern if what happen if there is a failure or there is a cross sensitivity of the carbon monoxide across other gases that can be, for example, hydrogen that can be also produced by people itself, and there is an alarm. This can be a kind of concern, but not easy to monitor indoor the carbon monoxide with a very conservative sealing. So this is my opinion. But in general, our sensors are not reporting anything above 3 ppm in general in indoor.
Mm-hmm.
In most of the environment, unless there are real source of carbon monoxide. That can be leakage from stoves or can be something infiltrating from the outside.
Thank you for explaining that. Can you please then clarify what is the typical use of your sensors in instruments? Is it used as to give an immediate sealing warning, like an industrial hygiene, an occupational safety instrument, or is it only calculating an average over time and reporting if the average is exceeded?
Well, our approach is to let the user set their threshold. We have changing colors, but the notification are normally starting from default settings, but the user can set their own threshold according to their own needs. And in general, we publish on the manual of the device that is mostly used in residential application or even in commercial applications, that this is not intended as a carbon monoxide monitor, not for safety, not intended for safety. Because if you go to use for safety, you need to rely to special regulations that are requiring a certain threshold, a certain average period over time, and also the alarm should be done according to this regulation. Like, for example, the level of alarm inside the device should have at least some decibels. Otherwise, you cannot qualify as a protection for carbon monoxide risk. And in general, the threshold that are for air quality are very different from the threshold for risk of carbon monoxide health poisoning. Because in general, conservative levels of carbon monoxide should be not above 4 ppm, but the instruments that are carbon monoxide sensors for safety are set to something to 20, 25 ppm. That raise an alarm and also takes in account if it's just short time or averaging over 8 hours, for example. I'm not aware, I'm not involved in this regulation itself, but we don't have to confuse air quality with safety from carbon monoxide, in my opinion. Totally different approach, even in terms of responsibility, because if one device that is intended for monitoring carbon monoxide for air quality for long-term exposure is failing to report an exceeding level of carbon monoxide that can be put the person in risk of health, this can be a problem. And also you have to rely on certification of the product itself, not giving a false sense of protection to the customers.
I'm so glad you mentioned that false sense of protection. Thank you so much for all of that information, but especially that last point. When you use carbon monoxide sensor in air quality instruments, do you black out any of the low level with a 0, or do you start the display from 1 part per million? And my other question is, how high do you go in your display for the public, which I don't believe is something that GoAQS is looking at yet for every pollutant, but I think down the road we may want to set minimum ranges for some of the pollutants. And I'm curious how high you go on the CO as well. Thanks.
Yes, you always start monitoring from 0.5 ppm with a resolution of 0.1, but the operative range is not something that exceeding 25 ppm. Also, to not go in false promise of health protection. These are choice that we done, no over 25 ppm, just to not overlap the use of safety device itself. And the device is not intended to raise an alert as a danger, but just a long-term exposure to low level of carbon monoxide, like for example, 5 to 6 ppm, in general can be a health risk, but not immediate risk of life.
Well, actually, the latest research, I will post a link in the chat today. The largest CO study ever published, some, excuse me, 337 cities, 18 countries, looking at mortality, found that for every 1 part per million increase in ambient from background, so starting at approximately 1 or 2 ppm background, every additional 1 ppm adds a same day increase in all-cause mortality, so total deaths, by about 1% for each 1 ppm. And this has been replicated in many other studies. That's just the largest. So I do think we need to either decide to tell the public that or decide not to tell the public that. But that is where research suggests CO is actually able to kill people on the same day if they are obviously vulnerable. And the risks are much higher, double-digit risk, if it is for respiratory disease alone. So I don't know where that ends up, but I like your idea of separating the display range from the low level to the higher alarm ranges. And in the US, different from Europe, CO alarms are not allowed to display below 30. So it would make sense for a home alarm, or a home monitor rather, I correct myself, for a home monitor to read up to 30, because that's the blackout range for the CO alarms, and a clear need there to fill that information blank for people who are sometimes feeling sick And now if they go to look at their device, a CO alarm gives them either no information or some misleadingly say 0. So I don't know if all this ends up in a Go AQS standard, but I definitely think we should prohibit the display of 0 unless it is a true 0. Thanks.
Yeah, and indeed, I have read in multiple also studies that they confuse the terms when it comes to carbon monoxide alarms and monitors to different things. They fall under different regulations by the different bodies out there. And we have to be very careful with that as well. So here, basically, we found all of the available standards and regulations and guidelines around carbon monoxide. We have only 2 of them recommending a ceiling value with minimum 12 milligrams per cubic meter and 31 milligrams per cubic meter. And then we have others with 15, 30, 1 hour, 8 hour, 24 hours, and 1 year, and undefined standards that didn't specify whether they have a ceiling number or their values based on an average.
Who is the 24-hour 3 milligram per cubic meter? What country has that?
I don't remember, but I think it's Poland, yes.
Okay. Well, there's one missing. I've been talking about the German standard for unlimited CO exposure that would not be harmful. And I'm remembering that it's either 1.5 ppm or 1.5 milligrams per cubic meter. I think it's 1.5 milligrams per cubic meter, so it would be closer to 1 ppm. But that would be quite different from these others that set an upper limit at which they say there would be some harm, above which they say there would be harm. This new German limit says you can have unlimited exposure below 1.5 and never experience harm. And that would be consistent with, or more consistent with, the epidemiology studies that show risks from even a single ppm.
By the way, I have reached out to the German professor that I've mentioned, and they have reached out to the German Federal Environmental Agency for more information regarding your question.
Oh, thank you so much. That's great.
And yeah, those was the number that we could find. If you can give me a reference, Albert, of this German standard, maybe we can implement it and have even stricter value for the 24 hours. So based on those numbers and looking a little bit also around the green building organizations, because they recommend some numbers, they focus around 10 micrograms per cubic centimeter. The language behind carbon monoxide is quite complicated. I don't think they understand. In some cases, they say that you have to inspect the building before it's occupied, and with one-time measurement, and that it's going to determine whether the building is going to be certified as green, which does not make sense to me personally. And based on the numbers that we could find, and I'm more than happy to update the numbers, we want to adapt the most strict numbers for the different average limits that we could find. So France was recommending 30 milligrams, Poland 3, German 10, and the latest paper from Professor Maroska was 35 for 1 hour mean exposure.
Well, wait, are you trying to get the lowest
Yes.
cited? Well, you're not there yet. There are definitely lower 8-hour standards for CO and the lower 1 hour, 35 for 1 hour. That's the EPA limit that was set. 35 milligrams would be about 30 ppm. But Europe has long been at a lower level, right? 30.
I mean, this is what I could find from the literature.
Well, I can get you lower. ACGIH is going this month to 15 ppm for 8 hours, and that's for workers.
Okay.
and the Dutch went to 7 uh, for workers um,
So,
for 8 hours. So the public shouldn't be exposed to more than workers.
mhm. No, absolutely, and some of the numbers they don't make sense either way. Like, and I think Kiro mentioned that during the survey that we shared with people out there, um, and we will see that in the comments later on. But those were the initial lowest numbers that I could find. But again, if you have more lower numbers, please share with them, and I can update those numbers.
All right, I'll
So
send that to everybody on the mailing list after.
yeah, and this is, for example, the comment Kiro shared with us. Actually, existing limit seems to be very high, mostly addressing safety. France limit for 30 milligrams, sorry, is so far from Poland at 1.3 milligrams per cubic centimeter. And again, that brings a question around whether we should adopt a ceiling limit and forget about the space adaptability that originally we discussed, but that maybe not does not make sense in order to protect the health of people from the different exposures of those pollutants, of this specific pollutant, to be more specific.
Remember, in practice, as we discussed at the beginning of the call, all of the manufacturers in this space of consumer products
Mm-hmm.
are making products that use the uh, regulatory average limits as ceilings.
Yes.
And so all the ones you've listed here, presumably one of them would become the selected ceiling
Mm-hmm.
that would trigger an immediate alert. None of the alarm manufacturers are using the averaging that is built into occupational instruments and home CO alarms, which requires a time delay as well as a certain level of CO before you can alarm. Nobody likes that. Nobody I know. And I wouldn't want to recommend that we move such averaging requirements into consumer devices. It
Well,
complicates the display, the readout, the interpretation, and it's less useful than the immediate warnings from exceeding a ceiling because the average warning can come up to 8 hours after the exposure is over, right? And
mm-hmm.
so I hope I'm being clear on this. I do think if GoAQS can be clear that it's talking about selecting averages that will be used as limits, then it's just a discussion of where do we think the notification limit should be? 3, 9, 25, 35, 50, 70. These are all limits of exposure attached to some time frame that we all agree we're just going to ignore the time frame. And for the sake of greater protection of the consumer, interpret these averages as ceilings.
Mm-hmm.
If everybody's okay with that, we don't have to pretend that the average means anything, and we should just pick the lowest number because it's the most protective.
Kiro, you have a comment?
Yeah, I fully agree with Albert about to make simple, otherwise too much complicated, not easy to implement. Let's say the perfect way is to use the average because what is dangerous for the carbon monoxide low levels is the concentration at the time of exposure. But this is not easy to implement in devices. And sealing can be probably having the effect of raising the alert, the attention to the user, and then probably bringing the right information to monitor over time if this level goes above another limit. It can be a way complicated, not easy to implement on carbon monoxide itself. And also about the study about 1 ppm is increasing a lot their issues, I fully agree. There are a lot of studies talking about this. But what is very, very important to divide, to make very clear the difference between low level of carbon monoxide for long time exposure that is giving health problem, cognitive problem to the brain, problem to the heart, problem to the health itself, and the risk of life that comes when the carbon monoxide is above 30 ppm. and this is immediate risk of life. This is a two different things that, for me, should be very clearly separated in the way we are presenting the GOIA QS.
Yeah, and this is the reason I have this slide, as you can see, where we talk about chronic exposure even in low concentrations and some of the symptoms that they have already documented, but yet the scientific community into investigating those levels and coming up with even stricter guidelines are not there yet, from as far as I was able to research. And Albert is sharing something with us now
Well,
here.
only the Germans have set
Okay.
a standard that acknowledges the reality of these epidemiology findings. And I put the link in the chat with that largest study, but you can find dozens more. There are no studies that say 9 or 20 or 30 are levels that are safe, that prevent death on the same day. The deaths occur on the same day that CO goes up 1 part per million. That is a very hard thing to adjust to for companies and researchers like me who've been worried about 9 and 35 for decades. But those limits were set when CO was higher. Now CO is less than 1. And the old 9 ppm standard, nobody knew when that was selected whether it would be low enough to protect people when CO is now less than 1. And we know it's not low enough because people are still dying from CO every day when CO goes above 1 part per million. And I would like us perhaps to think of requiring instruments to display CO levels that are now so low in parts per billion. And as we do with NOx and ozone, this would put everything on the same scale and immediately show people that CO exceeds all the other pollutants in the instrument combined.
Something else is that some of the standards that we were able to find out there, they had even lower values from what WHO is recommending for CO2 exposure. Do you have any comments on that?
Yeah, the WHO just made it up, just as EPA and most other regulatory bodies have done for 50 years. None of these limits are based on a single study, not one, that says exposure at a lower level has been tested and found to be safe. They're all based on studies of higher levels that were found to be harmful. And of course, that's not a comprehensive, logical way to set a standard. You should test the standard exposure levels at, above, and below to be sure you hit the right spot. And they've only ever tested above, except for these epidemiology studies. No other type of studies have tried to look for effects at lower levels, and all of the government agencies have rejected these epi findings, even though they use the same studies to support standards for particulates, NOx, and ozone. The EPA has very firmly said that the carbon monoxide studies are not good enough and should not be used as the basis of standards. I don't think GoAQS has to follow that necessarily, but I do think it has to cite something, and that's why I recommend citing the WHO, because it's well recognized, it's recent, and even though they made it up, it's much better than the EPA, which was made up 50 years ago.
Okay.
Can I add something to Albert?
Yes.
That, Albert told better to measure the carbon monoxide in ppb. I fully agree, because giving in ppm or in micrograms per meter cube gives the idea that 1 is 0. So there is no importance. The ozone is measured in ppb, and also for me, the carbon monoxide should be measured in ppb. For example, the official stations in Italy are still measuring the carbon monoxide in microgram per meter cube, and at this, the lowest number they can report is 0.5. That is misleading information if you're talking about outdoor environment. Because, like, for example, most of the time, the ceiling, the lower ceiling is rigid, and you don't know if you are 0.4, you are 0.3, You just know if it's above 0.5. And this gives false idea that the carbon monoxide is more related to the high level concentration, like 30 ppm, like 100 ppm, that historically is linked to safety rather than pollution that can have risk of a long-term exposure.
Okay. So those were some of the comments we received during the survey. Space sustainability needs to include manufacturing facilities. I don't remember who said that. Hospitals should be separated in restaurants and classified in 1 hour, and hotels classified in 8 hours. Basically, they are discussing how we should divide the different buildings in the different hours. Then another comment was...
Before you go on, let me ask about that. Isn't
Yeah.
it already a principle of GoAQS that it does not apply to occupational settings?
Exactly. We are not... We discussed that on a particular matter,
Right.
that we are not
So
going to...
manufacturing facilities, warehouses,
Yes.
restaurants, hotels, these are all regulated as occupational
Yeah,
workplaces, right?
you're
And
right.
I don't think it's appropriate to introduce these instruments in a way that might suggest to the employees that they're protected by whatever the instruments are displaying or measuring. And because of that, I don't think we should recommend any other settings than the consumer controlled owned settings that we intend, homes and other properties that people own that are not places where people are paid to work.
Yeah, you're right about facilities, manufacturing facilities and warehouse. They're outside of our REITs. They fall under the occupational safety and procedures. Yes, they do have very outdated standards, especially in the US, if we look at some of them. But it's very difficult for us to accommodate all of the different spaces. And for this reason, we will not have them included. And maybe I should write a statement inside the standard in order to make it more clear. Another comment was, I think that a single limit will be easier to implement and will avoid confusion among the public. However, I think work is needed to establish consensus based on evidence for what that level should be. And I think this comment falls under the current conversation we're having, right, with the different standards that we are exploring and what's the best way to approach this matter. As you have already seen some of the slides here, I talk a little bit about different concentrations of carbon monoxide and the consequences that it has on carboxyhemoglobin and the different levels, and what the literature says what safe levels should be, and in order to maintain a healthy neurological functions, but also cardiovascular functions as well.
I would quibble with all of that. Pretty strong quibbles for all of them. If you can give me a chance to give you other references, if you would take them. The first one I studied for my thesis, I know that's rubber, it's not true. The second one, we now know it's approximately 5 ppm per percent carboxyhemoglobin. So that would get you closer to 3% and 2.4, if that matters. And then the neurological outcomes, and there's a lot of research that says people are dying in the range of 1 to 2% from all causes at a higher rate than when they're below 1. So I don't think we should be talking about older literature that only looked for effects at higher levels when we now see death and serious disability occurring in the 1 to 2% range.
Okay. Yeah, if you have more research around them, please share them with me. And then again, as you already saw, we discussed a little bit about the chronic exposure and low concentration of carbon monoxide and all of the effects that they have already documented, but more research is needed in that space. This is something that Albert has shared me in the past, and the reason I'm sharing here is that I see that carbon monoxide is one of the most potent pollutants out there, alongside with particulate matter. But I think particulate matter has been investigated in more extents rather than any other pollutant out there. So maybe even carbon monoxide will be even more potent in the outcomes of health effects than PM 2.5 if had received the same amount of research from the scientific community.
Well, got the research. It was just almost all of it went into researching endogenous carbon monoxide health effects, not exogenous. But there are about 1,500 papers a year published on the pathway, and I'm thinking that's about what you have probably on particulate matter, right?
I mean, the research on particulate matter is endless. So many people have investigated the effects of the pollution with various mechanisms, various outcomes, and various concentrations in various places around the globe. Something that is not very common with other gases. Maybe because it's more difficult to measure, and maybe because in most cases we have instrumentation already deployed in a global scale that can measure PMs in a more robust way than all of those gases. And then one of the questions that I have is, which unit should we use? Like, which is the best unit to
Oh, wait,
measure
before you
carbon
go on
monoxide?
past that slide, please go back
Okay.
to that last slide. This is
Mhm.
why is this here and where will it go? I don't think it serves any purpose. I think we should be talking about death. Disability is for people who aren't dead. And I defy anybody to tell me why this is more important than the deaths that CO causes.
Well, health outcomes are as important as death. Personally, I don't want to suffer. I prefer dying immediately from any kind of causes. So I think it's very important for people to understand it's not only about deaths, that air pollution can kill you, but it's about also that can create severe health issues to yourself and live a miserable life instead of a happy and prosperous life.
Well, if you're going to include a disability assessment of CO, I want to again submit a paper that I think is a lot more solid than this one, because I went backwards in this one to earlier publications of the group to see where they got the CO number from. They got that CO number by greatly restricting the outcomes of CO that they studied to just two: heart disease, and I forget what the second one was. But obviously, CO causes a great deal more outcome than two. And so the particulate assessment was much broader and included a great many other outcomes. But because the CO literature was too broad for the authors to fully assess, they decided a priori to just pick two outcomes to include. So it's not an apples to apples comparison in this study. I can propose other daily studies, even though I think you really should show a death study, because you haven't shown death. If I agree both are important, but let's not say that the dailies are so much more important that you have a slide about disability outcomes and not about death. Because you can put death on the same scale. Many studies have done it by comparing the increase in mortality with each interquartile range increase in exposure. So even though the units of exposure are different, we just look at interquartile range and net effect per increase. And in almost all of those studies, CO and NOx will rank higher than particulates and ozone for whatever outcome you're looking at. But unless there's a reason not to put the deaths in, please.
No, there is no
don't be
reason.
including that.
Albert, there is no reason. Just didn't happen. Please share any research that you believe it's important to have included. I'm more than happy to review it and have it on our agenda. And then to follow my previous question, which unit is the best in order to measure carbon monoxide or communicate carbon monoxide out there? Recently in this conversation, Kiro mentioned about parts per billion and Albert as well. Do you think we should start like exploring communication with those numbers? WHO is using the milligrams per cubic meter, but
Well, we definitely should not use milligrams per cubic meter. No instrument can measure it. It's
I mean,
requires,
no,
let me
no
finish. It
instrument can
requires,
measurement, but they convert it easily. I mean, all
they
instruments have a
convert it
temperature.
incorrectly, Satyrs. They convert it incorrectly. They convert it in a way that no instrument can. It should not be cited because no instrument should even try to assess altitude, right, which is required, or atmospheric pressure and temperature in order to measure CO when they can do it in parts per million or parts per billion without that nonsense. And they're both metric, right? We're still in the metric system. And I urge us to stick with ppb or ppm. I'm so glad Dr. Miller was able to join us, and I wonder if you could comment, please, from your experience, if you think it would be helpful for researchers and also consumer instruments to be shown and discuss CO in parts per billion now instead of parts per million.
Well, that's an interesting idea. We are still doing it in ppm, but I like that because then you can get to lower levels. But I still think you should just use ppm, ppb, because then you don't have to do this conversion, and then you could have a mistake.
May I
Thanks.
ask, why do you think WHO is preferring the milligrams per cubic meter than the parts per million? Does anyone know?
I mean, I don't know. This is Shelley again, but I imagine it's so it can be a milligram per cubic meters compared to microgram per cubic meter. So everything is on a mass basis. I don't know if that's it, but it seems like that's why they're doing it.
Maybe.
And it doesn't make sense for gases to do it in grams.
Right. And it
I,
doesn't make
I
sense
think
even for smaller particulates, right? Like when we talk about
No, right.
nanoparticles.
it's
And
I
critically,
think it's more
I'm sorry,
I
go
think
ahead.
it's more historically to measure milligrams to the weight to the mass, even for gases, because chemistry started with weights rather than measuring particles in another ways. So it's more historical than practical.
I was just going to add the same thing. Thank you. That I've seen it in 19th century articles about CO. In the beginning, that's what they were doing, and as soon as instrumentation could give us parts per billion, they switched. And of course, then almost all exposures and ambient levels were in double digits. But now that almost all exposures are in single digits or less, I think we're misleading the public with these small numbers when, if we converted them to ppb like NOx and SOx and ozone, people would immediately see that CO is more than the others combined. And that would hopefully show up on dashboards in a way that would make sense to people than showing them different units, which, as we know, nobody can convert units in their head correctly first try.
No, you're right, and this is what I'm trying to avoid here. And I have seen that problem coming up in many cases where different group of scientists, let's say, they are talking about the specific pollutant, and someone is used in one way to measure them, and the other is used in another way. And they always have to, bring up the calculator in order to do the conversions. And it doesn't make sense. Why you don't agree on a specific way to measure them?
Well, I know you have to take another vote, but please, when you ask the ballot again, add ppb as an option instead of both, perhaps, because maybe there should be a specific question about, should the instrument be able to switch back and forth? I've been looking at some products from Chinese manufacturers, and there are a few manufacturers now who are bragging about a one-touch ability to flip all the display from ppm or ppb into milligram or microgram per cubic meter. But they're doing that, as they have acknowledged to me, with a standard assumption of sea level 25 degrees C, which is not the conditions inside most buildings even at sea level. So it's just meaningless gold plating of their instrument. It doesn't really add to the science, and I think it distracts from it. So I would not want my my clients rather to have that option. I'd rather just show them the PPB. Thanks.
And I see on the comment, Lula, Sally, Kiro, they all agree on the parts per billion. And it's going to help me write this document and this text inside and include this kind of information, right? Like maybe it's time for us to measure carbon monoxide in parts per billion. Let me share something from my personal experience working for a manufacturing company, of sensor manufacturing company, and having a client contacting us and saying why you are not giving us the values in micrograms per cubic meter. Specifically, they were measuring VOCs. We used to measure them in parts per million or parts per billion. I don't remember now, but they wanted the values in micrograms per cubic meter because this is how they saw the information in the literature. And it was like a consultant that wanted to have the instrument and the standard in hand from WHO, whatever they were following, and they wanted to have the values in micrograms per cubic meter. And for us as a company back then, it was easy to do that because the sensors inside the monitor had temperature and atmospheric pressure capabilities. So the conversion could happen instantaneously and accurately. But for some reason, they never implement it. They stick with the parts per million, parts per billion way.
Can we also have a vote on the question of the maximum range and the banning of zero for all sensors unless it is zero, not just for CO, so that if we're going to allow or encourage CO to be included, one question is it should display in parts per billion, and the other is what should that range be? Shelley, before you got here, we talked about starting at 1 and going at least to 30, because in the US, home CO alarms are blacked out below 30 and leave the consumer in the dark. And so there's a clear need in the marketplace, right, to fill that in. But in Europe, there is no such blackout. Displays are optional and can do whatever they want. So hopefully they could live with that in Europe if we set a 30 minimum. But because so many home exposures do get into the hundreds, I would encourage us to allow manufacturers to go higher. They can go to 300 or 3,000 even. If somebody opens a bag of coffee and you hold the detector over it, I know it's over 2,000, but I don't have an instrument that can tell me how much more.
Yeah, I don't think someone disagrees with that. Like, and especially if we start proposing the parts per billion, then zero is out of the picture immediately, right?
Well, no, zero is still a reading when the instrument is detecting less than 1/2 of its minimum detection threshold, right? When it doesn't get the signal, it should say zero. But with some instruments, there is a blackout band on CO alarms by regulation. In the US, they can't show anything until they get to 30. It's just supposed to be a blank screen, but some in violation show a zero, which is even worse, of course. So anyway, I'm just suggesting we could please, in your voting, to show the world what GoAQS has done. It would be good if we could vote on those questions about what's the minimum, what's the maximum, what's the optional upper limit.
We also have to consider if those sensors are able to measure lower concentrations of CO.
Well, Ciro, take that one and hit it out of the park, because I think you're not the only company that can measure 1/10 of a ppm these days, right? You have a lot of competition.
Let's say not in general, not easy to measure carbon monoxide with the low-cost sensors, mostly because of cross sensitivity with hydrogen. Normally, unless you are not using optical sensor, very selective sensors, cross sensitivity with the hydrogen indoor. Hydrogen produced by people can affect carbon monoxide reading. This is almost the experience, unless you go to higher level technologies like optical or others. So there is
So
a
I have
risk
to
of
challenge you on
plasticity.
that. I want to challenge you on that because I've got the spec sheets and actually tested several different brands of what are called hydrogen compensated or hydrogen corrected
Mhm.
carbon monoxide sensors that are still the basic electrochemical type. They still cost less than $5 or $10 wholesale, and their accuracy is much better. They're less cross interference with hydrogen. There's still some, but instead of say 100 ppm reading as 50, 100 ppm is going to read like 10 with the corrected sensor. So
No,
we
no,
could.
I agree. I'm just talking about all devices. For example, we have carbon monoxide almost sensitivity with ppb level of readings that works very fine, mostly for outdoor, but also for indoor.
Mhm.
But it's not common to all manufacturers, on my experience.
Is yours now hydrogen compensated?
Yes, hydrogen compensated, of course.
Great. So I think that answers the question. The industry is already there when they need to be.
Mhm.
Okay. Sally, you write a comment saying that I'm still concerned about health effects of exposure below 30 parts per million. Are you referring to as a ceiling limit or as an average exposure of specific time frame?
I'm just saying that because the low cost alarms that we can buy here in the US, as Albert was saying, just show 30 as the ceiling. So I would love to be able to buy a consumer grade alarm that can go below 30 and I can see it. I guess if it's in ppm, PBB. So I'm enjoying listening to your conversation about the availability of these monitors.
So at this, what we're talking about it would range from, let's say, a minimum of 100 ppb to a maximum of 30,000 ppb. And most of the time, people would never see those higher levels. But when there was any type of adverse event happening, they surely would see levels in that range. It's very common. And from cooking, from use of a vehicle started in an attached garage. So I think we should be encouraging the device makers to focus on this low end of the spectrum. And I think we should be pushing them to have a 0.1 ppm resolution now that that's more widely available. And we should push them to have the hydrogen compensation. If all of these things are available, I think that's where we should draw the line so that we don't introduce instruments that we know have these conflicts where people will think they don't work as well.
Perfect. Okay, time is almost running up. Any other concerns or final comments?
If I can add, I think
Yes, please.
what is very important, I think, very interesting discussion, but what is very important, probably neither the limit itself, but taking a decision on which information to give about carbon monoxide. If it's long-term exposure risky, and what are the effects on that? Even if it's simplified, it's much more than others are doing. So the starting point should be simple. Maybe in the next steps we can add more, but the decision I think should be to give an information that is consistent.
Mhm.
If I may, before we stop, let me ask Shelley, who came on late, what she thinks of this table, as clearly all of these were meant as averages. And what we talked about before you came on was Go IAQS selecting one of these averages, presumably the lowest, most protective one, and treating it as a ceiling, because the consumer instruments are not measuring exposure over time, but they are alerting people as soon as these limits are exceeded as if they were a ceiling. rather than an average? And would you support consumer instruments taking one of these levels and treating it as a ceiling and giving an instant warning? Or do you think it's more appropriate or also needed to show them what the true averages are over 1 or 8 hours like you studied in your research? Thanks.
Yeah, good question. I'm more of an exposure person. I'm like, what's the indoor air quality standard supposed to be? Not as opposed to what should an instrument have as a maximum measurement. So I can't really answer that question very well. But personally, what I like to do is have all the data and be able to average it on my own. And I appreciate here that you have different averaging times depending on the exposures. Um, so I don't really have a good answer for you, Albert.
I think, Albert, if you allow me, is the fact that we can propose all of those numbers that you can see on the screen, and later on the index that it's going to help communicate with the users, whether they should take action upon the air quality that they are experiencing at that specific moment or not. We can then propose a more strict and lower number than the already established standards based on the average timings.
Well, I'm not suggesting stricter lower time. Very specifically, I'm suggesting treating one of these numbers as if it were a ceiling instead of an average. Because no commercial consumer instrument, except in occupational health, which we've agreed we're not doing, no consumer instrument is even measuring and displaying these averages to the user in their dashboards. They're showing real time and perhaps a prior peak, which I think is really important to also require in our standards, that the consumer can see a prior peak. But I don't think they need to see the running average that Shelley and a few other people know how to calculate from minute to minute data. And if we can also have an option to get minute to minute data and have that downloadable, some instruments offer that, like the Yoo-Hoo. That's fantastic, because then we can put that in whatever tools we like and do whatever we want with it.
So you're talking about, so I'm looking at my consumer grade CO alarm, and right now the display says nothing, but that's because it's not detecting anything above, I don't know, I think it's supposed to, but then the alarm goes off at 30.
Oh, no, you're wrong about
So
that, Shelley. I got to correct you. Sorry, it's worse than that.
I don't even know, it's
It's so
like,
bad, right?
anyway.
You're such a knowledgeable CO researcher. It's not clear that this actually is only going to start displaying at 30, but it won't
Yeah.
alarm until it's over 70.
Okay, that's right. So it
And
might start
for 1 to
displaying at
4 hours.
30, but
Yeah.
it might alarm at 70. And then I have a button that says peak, so I can hit it and it will show me what the peak measurement was. So that kind of relates to what you're saying. What should we say is a peak? I guess is what your question is for these kinds of monitors.
Well, actually, that peak button simply shows what the last highest level was it recorded since the last time you pressed the button. What I meant
Yeah.
about the peak for the range is that some CO manufacturers, like Ciro's company, and I apologize, I don't even know the name of your company, are making devices that only display CO up to a relatively low level to stay away from alarm ranges. ISDA stops, AirGloss, thank you. AirGloss stops at 25. And as you know from your studies, their homes with more than 25 on a regular basis, they'll just see the word over or some symbol that indicates it's over range, right? But other companies are showing 300, 1,000, and I'm suggesting here we require a minimum of 30 to fill in this blank that all the consumer alarms have forced on us, where we don't get to know what's happening below 30. These devices could be specifically sold to fill in that blank. And I think the alarm companies would like that, because then they don't have to change anything they're doing.
Yeah, I mean, sure. So Tiras, if one of the goals of your project is to provide guidance to instrument companies, then that should be clearly laid out. Right now, I'm under the understanding where I was thinking it was more about like, how do we set indoor air quality standards for environments? But I can see the relationship between now we have to have a monitor to meet the needs of our air quality standards. So I can understand the discussion, but to be very clear on what you're trying to do is helpful.
Indeed, like we are trying to set limits for the indoor spaces, but at the same time, we need the technology to be able to follow them, right? Like, and
Right.
if we can also convince the industry out there of what they should do in order to follow those right steps, then it's a win-win situation for everybody.
Mm-hmm.
All right. I don't see any other comments or raised hands. So thank you again, everyone, for joining this session. I will try to summarize all the information and make it publicly within this week, hopefully. Although I do have other sessions, so please be patient with me. And once more, thank you for participating and sharing your opinion.
Just
you.
when you send out the minutes, can you put in there what is the next step? If there's going to be another vote, or what you expect of our advisory committee for the next step?
Yeah, I always do that at the end, so yes.
Thank you.